Okay, Token Drop episode 18. And what I'm going to do actually, since I'm traveling and my bandwidth is challenged here, I'm going to turn off my video and we can continue the conversation. So let me do that here. Okay, so what I'd like to talk about this week is I've heard this a few times recently, small language models. And the feedback that I've received is that there's companies who believe to give the AI domain knowledge. They can take a small language model and train it with domain knowledge from a customer, an industry, and that will infuse the small language model with the necessary domain knowledge to do a better job in whatever application that they're using it for. And for me, that actually I don't think works for a couple of reasons. One is if you look at language, it changes. Knowledge changes. And you spent all this time training, and if knowledge changes, which it does pretty consistently, you have to retrain your model. Doesn't matter if it's small or large. The second aspect is you still have hallucinations associated with a language model, small or large. So maybe what we can do this week is talk about small language models and pros and cons, things like that. So what do you think, Sajat?
Yes, I think, yes, you and I have been in several meetings where we have heard, some of those participants in those meetings tell us that they are uh, building small language models, domain-specific small language models, and they were pretty glib in the fact that, it would serve their needs. And our argument has always been that they share the same genetic architecture of the large language models, and therefore they suffer from the same consequences, which is errors and hallucinations, because they're going through the exact same process of training. And during training, you're storing knowledge in a lossy semantic compressive form. And during retrieval, you're doing probabilistic retrieval. So you have loss of potential loss of knowledge as the knowledge is being stored, and there's a potential loss of knowledge as the knowledge is being retrieved. And the compounding effect of that are errors and hallucinations. So you're spot on that these models also suffer from the exact same challenges that large language models suffer from. And therefore, you got to do it, at your own risk. And in fact, that brings to my mind two very prominent efforts in building small language models. There was one effort by Bloomberg in 2022. Bloomberg wanted to build Bloomberg GPT, and they spent about $10 million and trained a small language model. And a couple of years down the line, you must have read in the press that Bloomberg has stopped that effort because they're just not able to control the quality. And of course, there are other challenges I'll speak to. I'll let, and similarly, there was another effort by Meta. Meta built Galactica, which was a scientific model trained on scientific research and mathematics. And they were of the view that this becomes like the Oracle of Delphi, answering every scientific question, helping scientists and engineers innovate faster and build systems. But they had to literally withdraw that model within a few days of its launch because it was hallucinating so badly. They had to, in order to save themselves from reputational damage, they actually had to stop that model. So those are some, well-known examples in the industry where small language models have failed. It's not to say that they don't have benefits. We'll speak to those benefits, but I'll let Sam weigh in a little bit.
Yeah, sure. Thank you. Sujad has a vast experience in building small models very early in the cycle, right? So his experience is invaluable, as he was relating earlier when I was talking to him about what the history behind the small models were and stuff like that. So one thing, right, from my perspective, what I really think is, what do large language models do anyways? I mean, they have three jobs, right? They understand the question, they remember the facts, and they reason to an answer, right? I mean, these are three things, right? They sound good at first. You've seen our podcast earlier when we talked about the drop in the middle, right? Unreliable at second and inconsistent at third. This is the problem that we are facing with large language models. Now let's come to small models. Now, a small model also handles language, but the difference is a knowledge graph holds the facts. And then there's a third layer, a symbolic layer does the reasoning, right? Each part, now what happens is becomes testable, it's cheap and auditable. So this is the general pitch which the people who are experimenting with SLM say, actually, right? And the thing that they say that made the system untrustworthy, the model inventing facts is designed out instead of being filtered out, actually, right? I mean, so I think that is where this starts, right? But I want to really briefly touch upon where the SLMs really started gaining traction. It was around 2024, right? I mean, when SLM stopped being research result and became something you could buy, ship, and put on a device. Gemma, Gemma 2, 5.3, Llama 3.21b and 3b, right? Quen 2.5. A whole bunch of SLMs came into being, right? I mean, then when reasoning came in 2025, reasoning was based on distillation and DeepSeek R1 and subsequently other models, the Microsoft 5.4 mini and 5.4 mini reasoning, right? I mean, so some of these models came in, and these reasoning models were really they arrived small actually. And the small models then started growing up in 2026 when you have Quen 3.5, Gemma 4, GPT 5.4 mini and nano. So you have all variants which have come up actually, right?
Sam,
I
you
mean,
said, yeah, you said reasoning models are built by distillation. I mean, can you speak to that? What do you mean by that?
yeah. Actually, so when we talk about small models, there are really five different ideas that make them possible, right? One
So
is
you're saying, okay,
distillation.
the construction of small models from bigger models
Correct.
is through the process of distillation. So that is
Yeah, a small model can learn from a large model's full output
okay.
distribution,
Okay. Yeah,
not
that's
just a
one
trace.
way. That is one way. The other way is like in the case of enterprises who are our classical customers,
Yeah,
they build models not because the big models have that knowledge and are expensive to deploy. That might be one of the reasons. But a more motivating reason is they have proprietary knowledge.
correct.
So then they go out to construct from scratch small language models, not because they wanted to distill a large language model into a small model.
Oh yeah, yeah, totally, totally.
Might be one way to get there.
Yeah,
Really, I think many of the enterprises we heard of or spoken to,
yeah,
and in fact, some of the colleagues that we spoke with in the last few weeks
yeah.
were trying to build small language models because they had proprietary data that was not available to large language models. And they wanted to build small language models from scratch. So there are two ways of getting there. There's also a third way of getting there, which is in a large language model based on a MOE architecture, you are actually looking at multiple smaller models as well.
Correct, correct. Actually, that's where, Sujat, this is a very interesting area. Five different ideas, which when I was thinking about it, one was the distillation idea, which you brought about. I mean, two ways, right? I mean, so then there's this chinchilla, which is models were undertrained, not undersized, but trained longer on more data. That was the second part.
I'm
Third was
sorry.
the
I'm
quantization, right? 4-bit weights. Then you have curated and synthetic data, like the five result and the sparse mixture of experts which you brought in as a fifth scale is small scale 2026, right? I really think the most prominent idea which you brought up was the data that the enterprise holds private and is trying to bring it out. And also the second thing is a sparse mixture of experts, which is very, very important. It appears like a can you speak about that? Your experience
yeah.
with
Actually,
that?
I have a question here because you said, Sam, Llama 3.1 in a small language model. And I was surprising to me because I always thought Llama was a large language model. So maybe we can talk about what is a small language model?
Yeah.
What's a definition of one? It'd be
Right.
interesting.
Yeah.
My understanding doesn't seem to jive with yours.
Yeah.
Is there one?
I'll let Sajad answer that, then I'll
Yeah. I
answer.
think,
Yeah, sure,
yeah.
definitely. Yeah.
Yeah. It's a question of when you ask that question, right? So
Yeah.
if
Yeah.
you'd asked that question in 2017, when Attention is All You Need was published, and the model that Google had open sourced was BERT. BERT was the biggest model available to us, and that itself was quite an appealing choice in those days. But of course, as model parameters have grown, model sizes have grown, the definition of what is a small language model also might have changed a little bit, right? So these days, a small language model is largely something that maybe ranges from several billion parameters, maybe 1 billion parameters to
Yeah.
maybe 8 billion. They're typically treated as manageable small language models that can run on one GPU, entirely. But I think anything beyond that ends up becoming the definition of a large language model that requires multiple GPUs to serve inferences. The number of parameters they have is so large that they don't fit on one GPU. But don't take the benchmark of whether it fits on one GPU or not
Yeah.
as the definition of a large language model. So I was just giving that as a crude example.
Yeah, actually, to cite you, right, in 2019, there's something called Distilbert, actually, which was around 66 million, which is approximately one-fifth of Bert large, right? Then you go to 2021, 1 to 2 billions, approximately one hundredth of GPT-3, actually. You go to 2023, it's 7 billions, actually, approximately 1 by 25th, actually. Then you go down the graph, 2024, you have 1 to 3 billions, which is approximately 1 by 300th of a frontier model, right? And now, around what Sajad rightly pointed out, it's under 4 billions or approximately 4 billion active in an MOE. It's approximately 1 by 1,000, actually,
Maybe
right?
even
So the
up to,
absolute number moved around, actually. There's no
yeah.
stable definition of what is
Yeah,
functional,
it's
right?
time-based. You're absolutely right when you ask. But it seems like no matter when you answer that question, the problems still remain that, you still have to train it and knowledge changes and it still has hallucinations.
Indeed, I think the genetic makeup of that model prevents it from being accurate and precise all the time. So it does, like any large language models, it is prone to those problems. And uh, and I still think a small language model is a little bit of a step up from supervised fine tuning, right? So some people we have spoken to, Sunil, you might recall this. They say, "Oh yeah, but we'll bring that domain knowledge into LLM by doing some supervised fine tuning." And there are risks to supervised fine tuning, right? Like catastrophic forgetting, or you're trying to teach it new skills, new domain knowledge, and invariably it turns out that it doesn't work out oftentimes. Um, what I think we have read in the papers is that a model should have the priors. It should have the knowledge uh, built in through pre-training, and then you can maybe fine tune it for different use cases. There's a lot of papers referencing this as a more viable way of fine tuning. So compared to fine tuning, I think enterprises, many of the companies that we've spoken to, we've heard people tell us that they want to build small language models. That's definitely a step up from supervised fine tuning. But even over here with small language models, the risk remains, right? The hallucinatory risks remain. So what we need to start working with our customers on is something we did long, long ago. Sunil, I think in our old company when we were working out there in the year 2019, when BERT was relatively new, and we had a customer engagement for building a chemical and material science knowledge discovery. They wanted a platform for material and chemical science knowledge discovery. we had taken BERT, which was the biggest model those days. We had pre-trained BERT on chemical and material science data, and we had hand annotated documents using the Protoza tool from Stanford. In chemistry, material science, we had created ontologies, fine-tuned ontologies, and used that annotated data to fine-tune the BERT model. And what we ended up doing really was used BERT not in the direct query pathways, but to extract knowledge from documents and to construct a graph from those documents and use the graph for information serving. And I think what we did then in 2019, 2021 still holds. Even today, I think, if you chose to build a small language model because you wanted to train the model with your proprietary knowledge, I think more power to you. But you should use it wisely. And our suggestion is to consider using it for extracting information and to construct a graph. You could also use it for tokenization, domain specific tokenization, creating domain specific embeddings, and all of those are helpful in constructing information retrieval pipelines. So, yes, so there is some merit to it. I don't want to say that small language models are not very helpful. I think they're quite helpful. You can accomplish quite a bit, provided you're judicious about how you use them.
Yep, totally. I mean, I think you're right. But my fundamental question is um, the model should stop being the knowledge store. I don't believe it should be one. It should become a translator at best. I mean, two directions question, structured query, result, plain English, right? If it does that, now what happens is the translation becomes a very narrow learnable task, and it fits very in about 3 to 8 billion parameters. You don't need a huge model, right? The narrow task means you can actually test it also. The blast radius is very small actually, and also the practical consequences. It runs on your own hardware, no token per token bill that scales with usage, and the latency is in tens of milliseconds. We have seen that actually. I've experimented with that, right? And so the data never leaves. Now, fine tuning becomes cheap and boring, which is what you want, right? I mean, so you're not asking the model to be smart. You're asking it to be a good translator. And I really think this is a significant difference because these are two different hires, right? I mean, they're not the same thing. So, but the small models are worse, like what Sajjad earlier pointed out. They are worse the job you took away from them, but on the job that's left, the gap mostly closes, actually. That's what we're trying to say here. It's no better than that bigger foundation model in certain things. But we just took it away and wanted to be a mere translator, right? I mean, and that means where is the memory kept? The graph. The graph is the memory. The knowledge graph holds facts, the shape of those facts, and where each one came from, right? And every fact is a thing you can point to. It has a source, date, and answer, right? Update one fact, update one edge, no retraining, absence is explicit, the schema is the contract, and authored ones read by many, right? I mean, so I really think the graph is the memory, and weights are a memory of the conversation, but whereas the graph is a signed document, actually, right? I mean, that's the difference. And they build the graph as a retrieval index, a bag of notes anomaly to pull context from. That's a filing cabinet, right? I mean, the graph earns its cost when queries execute against it,
Yeah.
not it merely feeds text to your prompt, actually. That's
Yeah.
what people get wrong there, right? I mean, so having done that, then you get into reasoning, which splits deterministic from the fuzzy, which is basically, does this configuration violate a policy? Is mostly deterministic. Rules, constraints, graph traversal, solvers. This is very important. Whereas fuzzy means is Acme Corporation the same as capital ACME Corporation, right? The model, I mean, that does that. So these are two different jobs. Deterministic reasoning must be replayable, same question, same answer every time with a step shown. A model can't promise that, not because it's weak, but because it's not what sampling actually does, right? I mean, it's probabilistic at best in its nature. So therefore, I really think that's where we come from. Symbolic reason explains itself for free. The chain of rule is the explanation, and you don't need a separate explainability product, right, for that. That's where I really see it going, actually. I mean, if the answer has to be the same tomorrow, let not the model decide it. It should be a layer, which it's a symbolic layer that decides that, actually,
Yeah,
right?
yeah. Another thing that Sunil has been speaking about, which we haven't touched upon quite yet, is the fact that knowledge is changing. So you need to rebuild the model at certain point in time.
Right.
And in the case of Bloomberg, they had spent $10 million to train the model. And they published a paper and there's a lot of press about it. So that's how we know. So were they required to retrain the model every quarter? Because every time knowledge changed, you aggregate some volume of change and then go out to train the model. It's another $10 million. So if you're training a model 4 times a year, you're spending something like $40 million there. So very few people have the luxury of those kinds of budgets. So, and those that do, more power to them. But those who don't need to use other creative mechanisms to accomplish the goals they want to. And the other, I think, in the context of enterprise use, entitlements, right? There are documents, there's knowledge that different levels of people have different levels of access. And you cannot, burn that level of access knowledge into a language model. But you could do so readily on a graph. So if Sunil has access to some information and that neither of us should have access to, or if you have access to information that neither of us should have access to, then that level of uh, authorization and entitlement management can be readily done on a graph, less so on a small language model.
Exactly. I mean, I think one thing basically wanted to really highlight is earlier it was framed small means lossy, right? The student was always the compromise copy of the teacher, right? That framing stuck for years. Then you see most existing models were undertrained and there was headroom at every size. So naturally, what happened? Small models weren't compressed big models anymore. They were models trained correctly from scratch. That's how they started coming into being. But as Sujat made a very important point, the market for small models was not researchers economizing; it was privacy, latency, and cost. And three things a cloud API cannot fix at this moment, right? I mean, and therefore, I think what happened was that later they found out that reasoning was an emergent property of the size, right? It's not not an emergent property of the size. So therefore, it is a skill and it can be taught downwards. And that made it very interesting because then the trade-off has moved. Small models no longer give up capability; they give up breadth. The long tail is that these
No,
systems
I think,
are very
yeah,
specific.
Sam, I want to challenge you on that.
Yeah,
And then use the word reasoning a couple of times.
yeah,
Are these models really reasoning is a big question, right?
agreed.
So, and Subbarao Kamampati has published a lot of content in this regard, right? They've done years of research, PhD level research with multiple PhD students. I think what the conclusion they have arrived at is they're not reasoning. They appear to be reasoning, they appear to be emitting all of their, intermediate tokens. And when you assemble those intermediate tokens, you may or might not even be able to reconstruct that thought process. So it's not scientific, they're just simply recalling from memory. And if you really want to,
Exactly.
yeah, if you really want to do true reasoning, you have to take it offline and use
See, that is a very interesting point, right?
reasonings.
It's something, right? Are they really reasoning? I mean, and at that in that space, right? Um, should
Yeah,
should reasoning be outside, right? I
that's why
mean,
I'm hesitant to use words like emergent,
correct.
reasoning. These all look like magical properties,
Yeah,
right?
correct.
Where is the reasoning? Where is the wiring in the model to support reasoning, right?
Right.
So we haven't seen that wiring yet. We haven't seen the wiring in the model for mathematics yet,
Yeah.
right? So yes, I mean, yeah, we
So
got
so
to the jury's still quite out on that.
yeah. So my question is, what does it really mean when you say you can teach a small model how to work through your problem, right? I mean, is it, I mean, and maybe it learns those steps, memorizes them. We don't know actually. But again, that is the fundamental question is it capable of even reasoning at that level actually? And don't you really think of reasoning as something multi-step process actually, where you go, you ask, then you really again debrief, and then you go through again the same process. You have to go through that whole thing iteratively, right? This is
Yeah,
my
I mean,
understanding of it, actually, right?
yeah, I mean, for those who subscribe to this view, I think there is a point of view expressed by Andrei Karpathy at one point in time, and that was if you had human trajectories of thought, right? If you're trying to solve a given problem and your thought trajectories were well documented, maybe you could use those thought trajectories to train models with significantly lesser data to achieve real reasoning. But right now, a lot of the data that they trained on, the internet data, speaks about the outcomes, right? You know, um, I couldn't run a 1 mile race under 6 minutes.
Yeah.
So I trained hard and now I've achieved my goals, right? So, and that's what people tend to put on the internet. People describe the outcomes, less so the process that actually led to those outcomes. So, if there's sufficient quantities of that trajectories of thought, the process level data, there's a good chance maybe you can train models to learn those trajectories of thought.
Actually, right now, you also said a very beautiful thing, right? I mean, even Sunil brought it up. These large language models, right, we do not know exactly what to fix if there is a discrepancy in the knowledge, right? We do not know where to do that. So we can only retrain them fully, and that's a very costly exercise when it comes to foundational models actually, basically, and even bigger models for that matter. So retraining is a costly process. SLMs try to dissolve that a bit actually, because they're smaller in context, you can do that. I mean, that could be really a reason for what I would call people try to have an affinity towards small language models. But again, they have a place, I think, actually, and that place is rightfully where they act as translators, and they will be and the memory
Yeah.
is kept in the graph, right? That is my
Yeah.
opinion, actually.
Yeah. Sunil and I have been trying to figure out some language to describe how they fit into this architecture. And one thought that we had was use language models for the language skills, the linguistic. So when a query comes in, is there a way you can split the language part of the query from the knowledge?
Yeah.
And the knowledge and mathematics, can you offload from the LLM and perform it on an off-board engine?
Yeah.
Knowledge discovery, knowledge retrieval, mathematics, reasoning, logic. Can you perform all of these functions off board, then reconstitute the answer, and then let the LLM generate the final answer? So, in some sense, you've been using the word translator. It is literally a fluent language front end to the machinery in the back end that does knowledge processing, mathematics, and logic.
Yeah.
Okay, I think we're out of time, so I've
That
turned
was
my
a
video back on
fantastic
since we're out
discussion.
of
I
time.
loved it.
Yeah,
This is
Okay.
one of the best ones I had with Sujat and you. I mean, yeah, it's great. I
good.
mean, yeah.
Yeah, and my internet didn't crash, so I'm happy.
Yeah.
So we'll
Yeah.
talk to you guys later. Thank
All
you.
right.
Thank
Thank
you.
you.
Thank you,
Bye.
guys.
Bye.